All right, we're going to keep going with triangles and similarity, and we're going to look at some other ways to determine that two triangles are similar to each other. The first one is called the triangle proportionality theorem, and it just says that if a line is parallel to one side of a triangle, like this line is, and it intersects the other two sides, like this one does, then it divides the sides into segments of proportional length. So like this piece over this piece equals this piece over this piece. So if BE is parallel to CD, then AB over BC equals AE over ED. So a quick example for that, if PT equals 7.5 and TQ equals 3, SR equals 2.5, and it says find PS. Well, our theorem tells us that x over 2.5 is equal to 7.5 over 3. And we cross multiply, we get that 3x equals 18.75. And then we divide both sides by 3, and we get that x equals 6.25. So our problem, PS equals 6.25. And you can always check and see if your answer seems reasonable because 2.5 is less than 3, and 6.25 is less than 7.5. So that's a reasonable answer. Another example, same problem. I'll redraw the picture a little bit. Okay, so we have P, T, Q, R, and S. You want to get used to being able to redraw these pictures. So it says PS is 12.5, SR is 5, PT is 15, and I want you to find TQ, which is right here, TQ. So we have 12.5 over 5 equals 15 over x. We cross multiply and get 12.5 x equals 75. Divide both sides by 12.5. And we get that the side we needed, TQ, equals 6. And again, that seems reasonable because 15 is more than 12.5 and 6 is more than 5. So that's a reasonable answer. All right, the converse of that proportionality theorem just says that if you have two sets of proportional pieces like that, so A over E equals E over B and C over D equals D over B, then AC is parallel to ED. That's nothing too exciting. Okay, so a quick example. If we have a triangle DEF, so triangle DEF, and it says EH is 3, so H must be a point between E and F because EH is 3 and HF is 9, so this will be H. So EH is 3, HF is 9. And it says DG, so that must be some other point on there. So DG would go from D to G and then from G to F, so it's down here. So DG, this will be G. So this is 1/3 of this, so 1 to 3. And all it's saying is 1 over 3 equal to 3 over 9. Well, you can cross multiply and get 9 equals 9. And so that's true. So are they parallel? Yes. And that just means are DE and GH parallel? Yes, they are. All right. Another word that you're familiar with is a midsegment. So remember, a midsegment of a triangle is a segment with endpoints that are bisectors of two sides of the triangle. Every triangle has 3 midsegments. So over here, our 3 midsegments are RP, RQ, and PQ. Remember, the midsegment goes from the midpoint of one side to the midpoint of another side. The triangle has 3 of them. And hopefully you also remember that this distance right here is 1/2 of this distance. So remember our examples, like if this was 2 this was 2, and this was 2. So this distance is 2, this whole side is 4. All right, our mid-segment theorem says that if J and K are midpoints, so J and K are midpoints of FH and HG, then JK equals 1/2 FG. Not too bad. So let's take an look at what an example would look like. So in the figure, XY and XZ are mid-segments. So XY and XZ are mid-segments. So this is a midpoint. So this distance and this distance are the same. XY and XZ. So, and this is equal to them. And then our distance right here is equal to these two distances. Okay, so it says what's XZ? Well, XZ is from here to here, which is the same as Y to T, which is the same as R to Y. So XZ is 13 divided by 2, which is 6.5. ST, so from S to T is this entire distance here, which is twice as long as this mid-segment, which is 7. So because this is 7 and this is 7. So ST is 14. And angle RYX, so angle RYX, well, if you remember our rules about parallel lines, two parallel lines cut by a transversal have congruent alternate interior angles. So angle RYX is also 124 degrees. All right, last one. And these are all kind of the same idea, so that's why I'm going pretty fast through them. So if 3 or more parallel lines intersect 2 transversals, so that just means you have 3 things. This is like guitar strings. So you have 3 or more parallel lines. They look like guitar strings, right? And they cut the transversal proportionally. So AB over BC, AB over BC is equal to EF over FG. Okay, it just means that this over this equals this over this, and it's a proportional relationship is all we're working with here. Another kind of interesting thing that comes because of that is when that happens and you have 3 lines that cut over 2 transversals, 3 parallel lines, if the 2 pieces that it creates on this side are equal to each other, then the 2 pieces it creates on this side will be equal to each other also. So if AE is parallel to BF, and BF is parallel to CG, and AB is congruent to BC, then EF is congruent to FG. Okay? And knowing this just makes the problems easier because when you look at this first example here, we have our 3 parallel lines and they have the 2 transversals. So a lot of people are going to say that, well, this over this equals this over this. And you might even write it. You write 6x minus 5 over 4x plus 3 equals 3y plus 8 over 5y minus 7, right? When you start cross multiplying this though, you're going to notice real quickly that you have x's and you have y's, which is not an ideal situation for you guys. So what we didn't notice or we skimmed over was these little marks here that told us that MP from here to here is equal to PQ. So if those are equal, 3y plus 8 equals 5y minus 7. And if those two are equal, then these two have to be equal. So 6x minus 5 equals 4x plus 3. Now remember, that only worked because it told us here that these two were equal. But when that's the case, we can quickly solve these, right? That we've been doing this all year. All right, so we get 7.5 for y. And then we're going to solve this one. All right, y'all know how to do this. I'm not doing anything special for you. Okay. So that's a quick example. There's one more here if you want to practice it, but try to keep this video as short as I can for you. So look it over and have a good night.